So this week we're going to be talking about power sets. So I'm going to recall a definition we looked at before. Recall the definition of a subset. A set A is called a subset of a set B if every element of A also belongs to B. And then we're going to look at a few more definitions here. So we're going to define what a proper subset is. A set A is a proper subset of a set B if A is a subset of B, but A is not equal to B. And the notation we're going to use here is A is a there. That symbol means it's a proper subset. And so now let's talk about the power set. So the set consisting of all subsets of a given set A is called the power set of A. And is denoted P of A. So the power set, it's a set where all the elements they're all the subsets of A. So let's look at, before we look at an example, I'm going to give you some notation here. So notation, when we have a set A and we have these bars around it, this denotes the number of elements in the set A. So now let's look at an example involving power set. So for each set A below, determine the power set of A. In each case, determine the number of elements of A, or cardinality of A, and the cardinality of P of A. So let's start with our first one. First one we're going to look at. Let's assume A is the empty set. And we want to look at all the subsets of the set A. Well, the empty set only has one subset, and that's itself. So the power set of A would look like the set with just one element, the empty set. So here, the cardinality of A A is the empty set, so it has no elements. And then the cardinality of the power set of A is 1. All right, let's look at our next example. Let's say the set A has 2 elements, A and B, in it. And we want to look at the power set of A. So all subsets of this set. So the empty set is always a subset. And then we have sets containing just one element. So the set A and then the set B, those are subsets. And then the set itself, AB, is a subset of A. And there's my power set. There's all my subsets of this set A. And the number of elements in A is 2. The number of elements in the power set of A is 4. Let's look at one more. So for C, let's say A is the set 1, 2, 3. And what would the power set of A be? Well, the empty set is a subset of A. And then the set with just one element, 1, a set containing 2, and the set containing 3. Those are all subsets of A. And then let's look at subsets with 2 elements. You have 1, 2, 1, 3, 2, 3, and then the set A itself is also a subset, 1, 2, 3, and that's the power set of A. The number of elements of A is 3, and the number of elements in the power set of A is 8. So I do want to mention, let's kind of review these past 3 problems and what we learned. So in problem A, the number of elements in A was 0, and the number of elements in the power set was 1. In B, the number of elements in A was 2, number of elements in the power set was 4. And in C, the number of elements in A was 3. The number of elements in the power set was 8. And if you notice over here on the right, these are all powers of 2. So this is 2 to the 0, this is 2 squared, and 2 cubed. And if you look here at your exponents, they correspond to the numbers over here. And so I'll say, in general, the cardinality of the power set of A, it's 2 to the number of elements of A. So we're not going to prove this formula just yet, but it is something you should know, is that if your set has n elements in it, then the power set will have 2 to the n elements in it.